Well, here we go again. Another Miller and Kreisel. I know, shock face, right? So this one is a V-2B subwoofer, and pretty similar to all the other MX70s and 125s, things like that we've seen. Haven't even powered this one up. Once again, wanted to bring you along. I do have a speaker connected without a dummy load. So if this thing has a shorted output chip, it's going to make a loud hum and maybe pop the speaker. I'm not sure, but we'll figure that out when we cross that bridge. So first thing, I'm just going to power this up and see if we get anything. Particularly, I'm looking for this little red light to light up right here. And I did hear a thud, and I'm not seeing high AC current on the amp meter, on the variac. It is isolated, by the way. People keep asking about that. Yes, I do have a isolated variac transformer, so I'm completely safe. Everything is isolated from earth or hot or ground, whatever you want to call it, neutral. Everything's isolated. Well, that's a pretty good sign right off the bat. Let's go ahead and apply some audio to it. I'm going to shut the power off, let the capacitors bleed out till that light goes out completely. Then we will connect an audio source to it and see what happens. Okay, audio is connected, and I am connected to my signal generator. I have it set at 150 Hertz right now, so we shouldn't have any issue with the low pass filter. I have the gain on the generator turned down to 0. I have not touched the low pass filter adjustment or the bass level adjustment whatsoever. They are exactly as the customer shipped them to me. But they probably got moved in transit, so with this thing being wrapped in bubble wrap and whatnot. All right, once again, power on. And I hear some rumbling in the background. And I am getting signal output. Now I have my attenuator set at minus 30 dB right now, and then all of a sudden the audio level went way down. Let's go to minus 20. Let's go to minus 10. That's all I can get out of it. That is it. 0 dB. That's up all the way. This thing should be totally booming. So I'm going to go back to minus 30, and I'm going to touch the bass level control and the crossover frequency control and see if that makes any difference whatsoever. And it does, but I don't think that's the issue. If I can find a happy place. Only seems to be happy when I'm actually moving the pot. We'll put it back where it was. Same thing with the crossover pot. That's up all the way. Just on the chance it has a very sharp cutoff, I'm going to bring the frequency down to 100 Hertz. That's all I can get out of it. That's wide open. Okay, so at a minimum, I'm going to need to go ahead and clean these pots and then figure out why this thing has such low bass response, or such low output, I should say. I suspect a feedback capacitor on the power output chip, but let me show you something that I see right off the bat that I'm probably going to want to address. So let me go ahead and flip this board over, pull the cover off of it, and we'll take a look at it. All right, power off. All right, so two things right off the bat. Number one, this board's been running really hot in this area right here, and especially it's affected this capacitor. These are 100 microfarad 63 volt capacitors. Same as that one, same as that one. Notice the color change on this capacitor right here. It's been baked, and probably because of these two resistors right here generating heat. Even though when this thing is mounted in the cabinet, this capacitor is below these two resistors. Now these two resistors are what drop the 40 to 50 volts DC down to 12 volts, and it uses these two Zener diodes right here to regulate the voltage. And that's for the op amps right here. These are like LM348, yeah, LM348N op amps. Just a generic off-the-shelf op amp. Good quality, Nothing wrong with that whatsoever. So if this capacitor is in the feedback circuit, we could be having issues. There's also a 10 microfarad 63 volt cap right here. And this thing is really scarce on capacitors. Normally there's several more caps in this unit. And I see a spot for one. I thought maybe it broke off due to base, but nope. So yeah, we've got a 10 here, a 10 here, and 3 100s at 63 volts. I'm sorry, those are actually 100s at 50 volts. This must be a lower voltage model because normally these are all rated at 63 volts. Nevertheless, that is what they will be getting replaced with if it comes down to that, because these are Worth Electronic 100 microfarad 63 volt capacitors, and they are 105 degrees Celsius. Very good, and I chose these because of the extra low ESR. So at this point, I think the first thing we should do is go ahead and spray those pots and try it again and see if we get a positive change. I don't think we're going to. I think we're still going to have very limited output, but we'll go ahead and give that a try and see what happens first. People have asked, what do I use to clean the pots? Yes, it's Deoxit F5. This is for basically conductive plastic faders and controls. So if it has a carbon-based pot, this is what I use for that. Thanks to X-Ray Tony B for that recommendation. I know I've said it before, and I will say it again. So I'm just going to shoot it in here, rotate it, shoot it, rotate it, and then I'll speed this up and we'll come back to it in a few minutes. I'm going to alternate between the two pots as well. The last thing I'm going to do is just stand it up. I know it's going to be out of focus. And once it's standing upright, I'm going to go ahead and shoot it just to wash out any residue that might have been freed up inside this thing. And I'll flip this up the other direction and do the exact same thing for this pot here. A lot of this is going to evaporate, and the stuff that does not evaporate, I'll go ahead and wipe off in time. Okay, audio source is reconnected. Power this thing on. I hear nothing right now. I'm going to go ahead and bring up the gain a little bit. And so far, I'm very happy with the results. I'll take it from -30 to -20 dB. I'm just not getting the output that I want. That's it, wide open. It's almost like there's an AGC circuit, automatic gain control. Because as I rotate the knob, I'm basically at 0 right now. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's no difference in the audio output between about 1 and 10. That is it. And it does cut off at about 150 hertz. Let's go to a lower scale. So there's 10 hertz. I'm just not getting the audio output that I think I need to get out of this thing. Okay, let's pop the board off of this thing and check some capacitors and see what they have to say. I'm betting we're going to find an open or a very, very high ESR capacitor. There could be other issues. I'm not sure. We'll figure it out when we get there. So it seems like every time I service one of these, it's a slightly different version than the last one. So on this one, it's got screws that run up from the back with no heat sink. So the nuts go on this side. Normally the screws go down into the heat sink. So remember, when you're doing this, regardless of whether the screws run up or down, there are aluminum insulators on one side. And then on the other side, in between the circuit board and the STK chip, there are going to be fiber washers. Those are very important that they go back in the correct orientation. Then I'll move it into camera view. So yeah, these fiber washers go in between the circuit board and the top of the STK chip. Normally the STK chip just lifts off of this without much of a hassle. This one, yep, there it goes. So once that's up, we can go ahead and flip the board over. We can actually take a look at the bottom of it. So I'm going to go ahead and mark the locations of all these capacitors, and we'll ESR test them real quick and just see what they have to say. Well, I've got to tell you, when they manufactured this unit, they definitely had a little bit of serviceability in mind. I'm loving the way they designed this thing with an actual connector to disconnect everything on the heatsink from the main board. So this board can actually be completely taken out of the board without fear of damaging the wiring whatsoever. So I've got the capacitors marked here. I've got 110, 110, and the 100, 100, and 100. So let's go ahead and ESR those and just see what they have to say. Okay, first thing, I'm going to zero out my leads. And then we'll start with the two 10 microfarad caps. Hopefully things don't bounce around on here too terribly much. 2.8, that's not too terribly bad for a 10. And 2.4 on that one, not bad at all. These are the 100s. And that one is absolutely open. Open, open, open. That is probably the feedback capacitor that I suspect is defective. 4.4, way higher than I want to see. And 0.87, that's a lot closer. So at a minimum, I want to do a camp refill on the amplifier board. But let's go ahead and check the two main filter caps, because I really want to see 0.01 or 0.02 at the absolute highest on those. So these are Nippon chemi-con 7200 microfarad, 50 volt, 85 degrees Celsius caps. And try to get these wires to cooperate. Get the ESR tester, and it wants to flip over. I gotta add some pretension to it. Okay, well, that's as good as it's gonna get. So once again, I'm going to check lead integrity, and we'll do it on the board. And I want to see 0.00, and that one reads 0.01. I'm pretty good with the 0.01. Check the leads once again, and I'm seeing 0.02 on that capacitor. What about on the screw terminals itself? 0.02 and 0203. Wow, get better conductivity on the copper by far. It's in the 0.01, 0.02 range. I'm not too terribly concerned about that. I believe this is a slightly lower power amp, which is why it only has the 7200 microfarad capacitors in it. But let's go ahead, and I haven't contacted the customer yet, but I assume he probably wants to get this thing fixed since he did ship it to me to get this thing looked at. I think he lived in Arizona at the time, and I believe he has since moved to another state. So I'm just going to go ahead and replace all 5 of these capacitors, and we'll give it another try. Once I get this thing running, I want to look at the voltage on the Zener diodes right here and make sure that they are okay. And I think I'll do a load calculation based on the 300 ohm resistor they're using to drop the voltage, just to make sure that we're not going over the 1 watt rating of this Zener. I think it's a 1N4742 as I recall. Kind of see the numbers on it there, but not quite sure. And yes, it is a 1N4742. It's a 1 watt Zener diode. I do keep those in stock just in case one of those is bad. So I just want to bench test these new capacitors, check their ESR. Last time I tested these, they were just over 0.1 ohm, which is excellent for a 100. So I've got 0.13, 0.13, and 0.13. And now these 4.7s, I think they were maybe an ohm or two. Oh no, 0.64 ohms on that one. Gotta spread the leads open just a little bit. And 0.64 ohms on that one. Way, way better than the capacitors that are in the unit right now. Once again, I cannot stress the importance of marking the polarity of these capacitors. I have been burned here before, so I always try to mark the negative lead. so that I can get the capacitor in the right way, because like I said, I've been burned by the silk screening on the circuit board in the past. So I thought I'd go ahead and check these on the MK168. And that's not good. So this is one of the 10s. Oh, no, have it in the wrong part. Sorry, got to move it over one spot. Now, I did modify this test lead so that I can test some different components I needed to test. 10.7 microfarads, 3.7 ohms ESR, and a V-loss of 2.6% on that one. 10.57 microfarads, ESR 3.4 ohms, and a V-loss of 2.1%. Probably acceptable. So this is one of the 100s. 87.33 microfarads, ESR 1.3 ohms, way too high, but a V-loss of only 2.6%, not too terribly bad. And the next one, 62.5 microfarads, ESR 6.5 ohms, way higher than I want, and a V-loss of 5%. And this is the one that I think is the culprit for low audio. 750 picofarads. Well, if it were a ceramic capacitor, I'd be happy with that. But for an electrolytic, 750 picofarads is way, way out of the ballpark. I'm not sure it's even in the same county, the same state, or the same country. This thing is way out of the ballpark. Now, I am tempted to go ahead and resolder these resistors and Zener diodes that have been running so hot, but the connections actually look pretty doggone good. And one thing that happens to circuit boards after they've been running hot for so long is the glue that bonds the copper to the glass epoxy structure lets go over time. And if I solder these things, I may end up having to run jumper wires on them just because it lifts the traces off of the board. But as you can see, the connections, they don't look cracked. They don't look cold whatsoever. They've just been running hot. So I'm going to let this thing fly the way it is. I just don't want to dig a deeper rabbit hole than I absolutely have to. If they look bad, if they had rings or donuts around them, I would definitely run jumpers and resolder them. But I'm going to go ahead and add the silicone RTV to these things just to help bond them to the circuit board so they can't move. And I think this thing is going to be good for many, many more years. At this point, I'm going to go out on a limb and say that one 750 picofarad 100 microfarad capacitor was the issue with this unit. So I'm going to go ahead and temporarily set it up here. I'm going to measure the voltage across those Zener diodes and make sure it's roughly 12 volts plus or minus 10 or 20%. And yeah, okay, let's do that. Okay, everything is reconnected. I do have a speaker connected, but I don't have audio going into this right now. Let's go ahead and power this thing on and see what happens. So far, so good. So I did mark the location of the Zener diodes right here. So I'm just going to measure the voltage across them. 12.5 volts, I'm perfectly happy with that. And 12.68, very good on that. Now, I believe these capacitors are across the raw B plus coming in. So we have 37.5 volts on that one. and 37.5 volts on that one. So we're dropping the 37.5 volts through a 300 ohm resistor, then using a Zener diode to clamp that voltage at approximately 12.5 volts. I guess they just wanted no ripple whatsoever on this thing. Okay, so here's a quick look at the schematic for this output chip. And so this is the capacitor that was open, or 750 picofarads right here. And as you can see, it takes the speaker output through the emitter resistors, feeds it back through a 100 picofarad capacitor coupled with a 56.2K resistor and a 2.88K maybe, I'm not quite sure, and then that capacitor to ground, and it's on the negative feedback side of the STK output IC. So that is what the problem was. I'm very confident. I'm going to clean the board and put this thing back together right now. And we'll go ahead and give these pins on the Molex connector a little bit of extra pretension. Okay, everything's all back together. Molex connector's been retensioned. All the large components, including the capacitors I replaced, have been silicone down. I did not go ahead and silicone the 10s. They're very, very small. I don't expect any issues with those. But I did go ahead and silicone the 100s as well as all the large resistors just to keep them from vibrating. So here we go, power on. And I have my signal generator set to 100 Hertz with a minus 30 dB attenuation. The base level is at 3/4 right now. The crossover is as high as it'll go. Big difference. Yes, definitely working good. Let's go down to maybe 30 Hertz. Oh yeah, it's shaking the lights. Big difference. Well, let's put music into it and wrap this thing up. Okay, here we go. Base level is at minimum. I do have an MP3 player connected to it. Power on. Let's bring up the level. And it's working absolutely perfectly. Look how low the base level is. That is working excellent. Anyhow, I say that we have a very solid repair on our hands on the Miller & Kreisel V-2B Subwoofer. Go ahead and leave me a question, a comment, a concern down below, good or bad. I try to respond to the comments when I have time. While you're down there, if you could, please hit that subscribe button and like this video. It does help the YouTube algorithm serve up these videos to people like yourself that might be interested in a Miller & Kreisel subwoofer repair. You can follow me on social media, Facebook, Instagram, Twitter at NorCal715. You can email me norcal715videos@gmail.com. That is the best way to contact me. Please be patient, however, I do have a full-time job and I do these repairs in my spare time. If you try to contact me on Facebook, Instagram, or Twitter, please be aware it might be weeks, months, or I may never respond. I rarely check those messages. I occasionally post a video or a repair or just a progress report, but that is about it. Please, if you want to contact me, use the Gmail address only. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everyone, thank you for making it to the end of this video. I really do appreciate it. Everyone, stand by for bloopers. Once again, thank you so much for watching. Bye-bye. And I did decide to go ahead and add RTV to those two 10 microfarad caps as well. Thanks for watching. Okay, so I remember I was going to tell you about, we'll calculate the watts and current across the drop-in resistors and Zener diodes. So let's go ahead and calculate watts on the resistors first. So we certainly know the E and the R. E is the voltage, R is the resistance. So the voltage is going to be 26 volts drop across the resistors, which is 38 volts. I rounded it up. And a resistance of 300 ohms. So we'll hit calculate. And so it says that we are dissipating 2.25 watts per resistor. And that's definitely within the acceptable range because it is a 5-watt resistor. Now let's go ahead and calculate the current, which we're going to need to do the next calculation. So once again, we know E is going to be 26 volts. Resistance 300 ohms. And we calculate that out to 87 milliamps. Now we can go back to watts. And so we know E and I. So E, which is the voltage, is going to be 12 volts. Well, let's just say 12.5 because that's what they measured at. And the current is going to be 0.087 milliamps, 87 milliamps. And we can see that the Zener diodes are dissipating 1.09 watts. Now that's unloaded. That's if the op amps and the other circuits that use that plus and minus 12 volt power supply are not loaded. Once you add load to that circuit, the current is going to come down. So they're pushing these things, I'm going to say, basically to 1 watt or maybe 0.9 watts. A little bit high in my estimation, but the engineers thought this was a great idea, and it seems to be working just fine. I've never had a Zener diode failure on one of these. I've never had a 5-watt resistor open on one of these. I have had some that run very, very hot. Okay, just a little addendum right there. This is the Android app called Ohm's Law Calculator, if you're interested. Just an addendum once again. Everyone have a great day. Thanks for watching. Bye-bye. And I'm not seeing high DC current. And it uses these two Zener diodes. And it uses, that's well conduct, I betcha. And I see 0.0. And that one reads 0.02. Let's take that over. I do want to take a look at, last time I tested these, they were around 0.05 ohms. These are 0.14, I'm sorry. Let's take that over. Obviously reading the wrong label. Well, if it were cement, I'm not sure it's even in the same state, county, or country. So here's a quick look at the schematic. This is the capacitor that was open right here, C203. And as you can see, it's in the negative feedback to the input of the STK chip right there. Okay, let's try it again without moving the paper. And let's go ahead and put this thing back together now.